Welcome to the Feisty Women's Performance Podcast. I'm your host, Sarah Gross, Ironman champion, PhD in women's history, and founder and CEO of Feisty Media. I started this show because I wanted to cut through the BS of diet culture and fitness culture and actually learn from high-achieving women at the top of their game who have figured out how to feel and perform their best at every stage of life. So I chat with experts, elite athletes, and leaders who have learned to succeed despite the massive gender data gap in exercise and medical science and product development. Every episode is filled with information, advice, and anecdotes that will help you fulfill your potential as an athlete, mom, leader, or business owner. And listen up. If you don't subscribe to our Women's Performance newsletter, you are definitely missing out. It's totally free. So head over to womensperformance.com and subscribe now. That's womensperformance.com. This podcast is a production of Feisty Media. Hello, Feisties. Thank you for listening to this episode of the Women's Performance Podcast. Today's guest is basically paving the future for how we understand muscle repair, and how we stop muscle degeneration, which is something we all need as we age. Silvia Blemker is a professor of biomedical engineering, mechanical and aerospace engineering, and orthopedic surgery. And as if that isn't enough, she is also the founder of Springbok Analytics, a company that uses AI-powered technology to deliver insights for muscle health, performance, and longevity. Silvia is also someone who noticed early in her career that most of the science and therefore information we have about human muscles in particular is based on data from male subjects and simply scaled down to apply to women, a model that we know does not work. Today, Silvia and I chat about her research projects, how sex differences affect every part of our bodies from movement and coordination to our muscles, cells, and their molecules. We also talk about how AI is creating rapid change for women's health and sports performance, and why women, on average, have better calves. I mean, it's science. Can't argue with science. Hi, Silvia. Welcome to the podcast.
Hi. Good to see you. Thanks for having me.
No problem at all. I'm excited to talk to you. I was, reading all about you last night, the things I could find online, and I'm so interested to learn more about your work. But first, you were a dancer growing up. Am I right about that?
Correct. Yep. Ballet mainly.
Oh, amazing. And do you still have an outlet for movement in your life right now?
I do. I don't really do ballet anymore, sadly. But I play tennis. I love playing tennis now. I took it up in my early 40s, and now that's kind of my favorite hobby.
Yeah, cool. And is biomedical engineering. Okay, it's such an interesting field. We used to have someone who worked for Feisty Media who was a biomedical engineer. And to be really honest, I'm not entirely sure what she did. So first of all, what is biomedical engineering?
I like to break apart the term. I think it helps understand it because it brings together lots of things, which I think is what a lot of people love about it. So biomedical engineering. So bio is really kind of, obviously bio means life. So, and so we study biology, life, living things. Medical is obviously all related to human health. So we're interested in leveraging understanding of biology to improve human health. And then the engineering is really bringing in that problem solving aspect. Also some physics, math, and science. So we kind of leverage engineering concepts to solve problems in human health. It's kind of the way I broadly define it. So that could mean so many different things, like from, genetic engineering or so-called regenerative medicine, coming up with new ways to build new, regenerate tissues, build new organs, or a lot of people think about prosthetic design as a good example. A lot of people, the students, actually get interested in biomedical engineering thinking about that because it's clearly an engineering design problem to help people with their movement. I personally study muscle biomechanics, so I'm really interested in understanding how muscles work and why they don't work or what makes them work really well. And muscle's super complicated. There's a lot of biology there, but a lot of physics involved in how muscle contracts and moves, helps us move. So bringing in engineering tools helps us really understand that better. We build computer models of muscle. We also develop new ways to study muscle, to quantify it, to understand how it's working. So,
Yeah, and as I understand, some of your research can be applied to folks who have various diseases or who have like chronic illness, but also to elite athletes. Like it runs the gamut that way.
yeah.
Mm-hmm.
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 Yeah. I actually find in some ways that helps us understand the system better to know the whole range. So going from disease to healthy to kind of super performing in a way. And the other way I think about it is, and I think this is like one of Nike's slogans, which I really appreciate. Everybody's an athlete. So
Mm-hmm.
whether you have a muscle disease or you have, you're recovering from an injury, or you're an elite athlete, or you're, a 40-something-year-old female tennis player, we all care about our movement, and and so that's kind of the way I think about it in terms of the application of what I'm doing and why having such a broad range makes sense.
Yeah. And how did you find this interest? Like how did you get into this field?
Yeah. So actually, I kind of wanted, I think when I was younger, when I was young, I thought anatomy was really interesting. I used to have these models of different body parts. I was a total nerd. Like I had an ear and a heart. My mom got me these different models that I had to put together. It's sort of like not a model car, but a model like organ. And they were super cool. So I was really into that kind of thing. But I liked math. And my father was a mathematician, so we had like a lot of math in my family, and physics. So then my mom got me this book called The Physics of Dance, because I loved dance obviously too, and that really got me thinking about like looking at the human body in terms of math and physics. I thought that was really interesting and cool. And then I learned about biomedical engineering programs. They were actually, when I applied to college, biomedical engineering curricula or programs were pretty rare. There weren't that many around at that point. But so I hadn't even heard of it really. But I got a letter in the mail, like from a college. I think, after you take the PSAT, you start getting letters of information. And this one college sent me this information about biomedical engineering. And I was like, what's that? My parents really helped me sort of explore it a little bit more. That was before the internet. So it was harder to learn more about new things like that. But that's where I got started. I ended up studying BME as an undergrad and
Oh,
kind of
wow.
never looked back.
Yeah, I didn't even realize it was an undergraduate degree.
Yeah. At that point it was rare, but now pretty much every major or even smaller engineering school has a biomedical engineering program. And actually, it's often the most popular major of engineering.
Huh. That's just my age showing through, I think. I'm in my 40s too.
Yeah.
So I think I
Yeah.
went to college in those years. It was like, what is that?
Yeah. Yeah. No, but when I was in college, people would be like, what? But now it's like common. I teach at University of Virginia. Like
Mhm.
every kid will know what a BME is, like
Right.
it's a normal thing now. Yeah.
Right. And
Yeah.
that's so exciting, right?
Mm-hmm.
But yeah,
Yeah.
tell us a little bit too about some of your research projects that you've worked on.
Yeah, it's a huge range. The themes are skeletal muscle. We do a lot of computer modeling, so essentially using math to better quantify how muscle's working and understand it better. We use a lot of imaging and different experiments in the lab. So a few example projects, we're really interested in muscle disease, in particular various forms of muscular dystrophy, where there's progressive degeneration of muscles, and we're trying to better use our tools to better understand how that degeneration works, what that means in terms of the movement, how movement influences degeneration, and kind of that circular process, and ultimately coming up with new concepts to help inform new therapies and treatments. And then, that's on the muscle disease side. We've also done a lot of modeling of different muscles related to surgeries. So we are interested in using a model to say, oh, well, can we help use this model to simulate different surgeries and help surgeons come up with better ways to improve their surgery, to improve the outcome from their surgery. Then on the athlete performance, we've used our image modeling tools to understand, number one, even like what muscle distributions look like in athletes. And even we have a cool paper that just came out where we compared the muscle volumes or the muscles across the whole leg in a whole bunch of different types of athletes, and see if we see trends in like which muscles tend to be more prominent in which types of athletes. We had sprinters, we had baseball players, basketball, football, soccer, so a whole range. And so what was interesting there was that, it's kind of intuitive, but we got a lot of into the detail of this. Like what mattered more was more position than sport. So like specific football players look more like sprinters than, and some baseball players look like sprinters, but not maybe more like football. So they kind of mixed in terms of sport, but then in terms of position, we saw a lot of some consistency there. So
right, super interesting. Is that the study where you found that women, once and for all, that women have better calves?
Oh no.
I mean, we knew.
But we knew that.
We knew. But science, you can't argue with science.
Yes. No. It's actually one of my favorite things when we spend all this time studying something. We have all these detailed questions, and then you kind of zoom back out to the high level answer, and it's like, well, anybody could have told you that. But it's still satisfying that we came up with an answer that's but we drill in a little bit more on it. But no, that was unfortunately, I have obviously a strong interest at this point in understanding sex differences and understanding implications of that, and kind of drilling into that on the muscle side. But that particular study, admittedly, was all male athletes. So yeah,
right.
So that was a huge limitation of that. And I can explain, there's a lot to why we end up in those positions. That particular study, it happened to be that, we were leveraging, in order to do that study, we were leveraging the networks that we had with the different UVA teams. And my colleague who had those connections happened to have those connections with the male staff, the staff for the male teams. So that's kind of how it came to be. So
how it came to be has kind of been the way it has been sort of for a really long time. When did you first notice that we were excluding women from these studies, from studies broadly? And then when did you first think, oh, maybe that has an impact on our outcomes or an impact for women's health?
Yeah. So I think it's a combination of noticing it for my own work, where you kind of a lot, that's so much of what we do is okay, this is what you do, it's and when you're so focused in these cases, so focused on your specific questions, there's so much going on, so much complexity in the research questions, that whenever you can do something to make other aspects simpler, that obviously makes the study more feasible, right? So focusing on male was really the answer why, because it's easier to do for multiple reasons. You don't have another variable, so that's decreases the number of samples you need by a half, essentially. And also perhaps it's easier to recruit male subjects for this particular thing. That paper I was just describing is another good one. There's lots of reasons why, okay, within the confines of the resources that I have, this is the way to get this project done, which is good for a student, all these other things. But notice kind of in doing that, noticing like, oh shoot, like this is what that means. So there was that piece that I definitely was starting to wear on me. Like, why are we doing that? We need to do better than that. And then also, you read the same thing, you read the literature and you don't really notice it for a while until you realize, oh, that's all male subjects, or all that's male mice or male rats. It's all male. And maybe they've justified it, maybe they haven't, but still it's all male. Mm-hmm. And then I think the one moment where it really, like, for me, actually kind of came all together, like I'd been noticing all that stuff came all together, mm-hmm. was actually I was just sitting at a conference. I don't even remember what the specific conference was. And there was a student presenting a project on muscle. It was like a muscle physiology. They were looking detailed at muscle fibers and their property and had a specific question. And they used all male samples. I think it was from mice, I think. And I raised my hand. I was like, okay, well, why all male samples? And it was a graduate student standing there. And I was trying to, I don't like to be like mean to grad students in questions. I was really curious. Like, how are you guys? Yeah, like I'd been thinking about this issue myself. So I'm like mm-hmm. starting to ask others, like, what leads you to do this too? I really want to better understand this. And the student's answer, he was totally honest. He's like, well, that's just what you do. It's like, oh, okay. So this is what, like, the next generation even thinks. It's like, mm-hmm. that's just what you do. Like, this is how you do it. And so I think that definitely that experience and all the thing to just feel the fire of like, well, we don't have to do that. And the truth is that we don't know, like, and I will say there's been a lot of people in especially in the kind of biomechanics world who have been interested in sex differences for some time. So that's definitely been something a lot of people study. I would say it's oftentimes a little bit more peripheral or fringe, so to speak. And maybe motivated in specific areas like ACL injury, for example. We know that that's much more common in women than men, especially like young women. So that's been obviously an area of like figuring out why. Right. But I will see in the mainstream world of biomechanics, it hadn't really kind of made its way in there. So it's like the world has been making conclusions about specific areas of like how movement works, what muscles do, and all this kind of stuff, but with underlying assumptions that have to do with just studying men. And so really like infusing that into like the broader community, I feel like was kind of what I was motivated by.
As we head into summer, rest and recovery are critical for improving sports performance, reducing stress, and living a long and healthy life. We should all invest in better sleep. So, think about the thing you lay your head on for 8 hours a night. If it's not exactly right for you, it can lead to needless tossing and turning, or worse, have you waking up with an unrelenting kink in your neck. My new Lagoon pillow has helped me improve my sleep immensely by pairing me with the performance pillow that has everything I need. So I personally was matched with the Otter pillow. Shout out to Team Otter, which I love because it has a gentle cooling effect. And I was able to choose how much stuffing I wanted in it, which is super important to me because I'm doing a decent amount of CrossFit these days and my shoulders are kind of creaky. So having a pillow that is stuffed just to the right height keeps my neck and head in exactly the right position and comfortable for the entire night. And as of fall 2023, Lagoon launched their 100% mulberry silk pillowcases. It's cool to the touch, buttery soft, and great for your skin and hair. You've got to go check out this pillowcase if you want to feel great and look great every morning. Waking up for morning workouts has never felt better. I'm refreshed and pain-free thanks to my Lagoon pillow. To check it out for yourself, go to lagoonsleep.com/performance and take the 2-minute sleep quiz to find your perfect pillow match. And then use the code PERFORMANCE for 15% off your first purchase. That's code PERFORMANCE at lagoonsleep.com/performance, whole 15% off. And the link is in the show notes. You can just click through there. As a lifelong runner and triathlete turned CrossFitter, I am stoked to announce that the athletic eyewear brand Tifosi Optics has joined us as a partner here at Feisty Media. Tifosi sports glasses hit all the marks for athletes. They're shatterproof polybicarbonate, so the lenses not only reduce glare, but also offer scratch resistance, which I 100% need. They stay in place when you are moving. The hydrophilic rubber nose pads actually get more grippy the more you sweat, so they are secure and don't slide down your face even when you're running in hot conditions. No matter what sport you do, Tifosi has shades for you. Whether you love tennis, fishing, pickleball, running, cycling, or just hanging out on the beach. They are super reasonably priced, which I love, so I can have multiple pairs that go with any outfit. And of course, Feisty listeners get a special discount. So head on over to tifosioptics.com and use the code FM20. FM as in Feisty Media to get 20% off your order. That's FM20 at tifosioptics.com. I'll put a link in the show notes to make it easy for you. Can you explain a little bit about how does including women in those studies, how does it create better outcomes? Because there are some ways where we know that some of those studies that are done on only men do have outcomes that can be applied to women as well, and that have been working, in medicine or in sports science. But what are some of the ways that it doesn't work just to apply a male model to a female athlete or a woman, just in general?
So an example, I think there's a lot of cases where we don't know.
Mm-hmm. Right.
We don't know what we don't know
kind of thing.
Yeah, right. Exactly. I think a lot of cases are, some obvious ones are things like when hormones have an impact on a treatment or an outcome, or a process, that really should be taken into account. But is, if you only study males, obviously the estrogen, female hormones aren't even a part of the picture, number one. But then number two, the impact of those hormones on the outcome could really be profound, in some cases, because for example, in my lab, we're studying muscle regeneration from injury. Mm-hmm. And there is now a fair amount of data to show that muscles, the time course of muscle regeneration, how well muscles can heal from an injury, is influenced by how much estrogen is. And more estrogen generally is better, faster healing, better healing. And so, without having that as a factor, it's you're just studying male muscle regeneration. You wouldn't even the answer you get could be completely different if you were doing the same, if you're trying a different treatment or some other thing, if you had the hormones overlaid with it. So
right. So if muscle repair is degeneration is slowed down. No, muscle repair is slowed down by the lack of estrogen. Is that what I heard you say?
Mm-hmm.
Yeah. So now I'm thinking, okay, does that have implications for women in menopause or perimenopause, as we age? Does it have implications through a regular cycling, through the menstrual cycle?
Potentially. Yeah. Mm-hmm. I think it has implications, all of those things. It has implications, definitely perimenopause and menopause. It has implications on menstrual cycle for sure. I'd actually even use of birth control too, honestly, because birth control modulates the hormones levels in your body. And I know this is a somewhat of a big kind of question about birth control use and controlling menstrual cycles in female athletes. And for sure, like this could have a big impact on their injuries and especially soft tissue injuries and how they can heal and all that kind of thing. So yeah, I think that's a really important area of study that I think really needs to be figured out in order to help improve, like really empower the female athlete.
Yeah. And you might be at step 1 of learning about this, and I'm about to ask a step 3 question, but like, is there an effect with like synthetic forms of estrogen that we could take that would then still help our muscles regenerate faster?
Maybe. Yeah. Yeah. Maybe.
It's possible.
I don't know. Yeah, it's possible. Or, the other ideas would be, the other things we're thinking about is like, if the absence of, there might be ways to modulate like best approaches for enhanced healing of muscle, that to account for the lack of dystrophin. I'm not dystrophin. I'm sorry. I said dystrophin. I study dystrophin also and estrogen. So that's one way to think about it too. So perhaps it is estrogen supplementation, or it could be modulating how best to treat, accounting for the presence of estrogen. The other thing that we're still trying to figure out is like, is there a too much also? When you're pregnant, there's really elevated levels of estrogen, other points as well. There may be kind of a Goldilocks phenomenon that would also be important to understand. So like sort of too high, too low, and just right kind of thing.
Right. Interesting. And to be clear, like this is something, what we're talking about is something that affects all women as we age. Right.
Yes.
Yeah.
I mean, all women.
It's not
yes.
just,
yeah.
It's not just athletes. Right.
Yeah.
Yeah.
All women. Mm-hmm.
Yeah. And I saw one of your slides on one of your presentations yesterday. It was very interesting that how like sex differences affect us on every level, which is not a surprise, but just seeing that sort of broken down from like basic, like from muscle coordination or movement coordination to like the muscular level, like we're talking about, to cellular and molecular level. And I've heard people say that before, but I've never fully understood, like, how do sex differences affect us on all of those different levels?
Yeah, that's a good question. So a few examples that may be somewhat tangible, like if you look at the, composition of muscle, so you're looking at the muscle cell is a muscle fiber, right? And then you look within there, then you have all the contractile, like the proteins that allow your muscle to contract and everything. So even if you look at muscles in female versus male, there is a trend to have different types of fibers / kind of proteins within fibers between male and female. I think my understanding is that in many muscles, there's trends to be more type 1 fibers, which are the slower velocity / a little bit more endurance resistance. Though that's somewhat adaptable, but
right.
But more versus the type 2 more explosive power generating fibers. That like overall, that trend tends to be like when you study women and men, you tend to see that difference. And, a bigger question is, where is that coming from? Is it really a pure genetic difference in the, genetic makeup of male, female, the chromosome difference that may lead to these differences? Or is it some sort of an adaptation over time, different activities?
And we don't know the answer to that?
No.
Oh, interesting.
Yeah.
Okay.
Yeah. It's quite hard to study, really.
Right.
And it's, but there's actually been, maybe I'll digress just a bit. There's a lot more biology tools now to better study, like really purely what's leading to differences, sex differences, different like mouse models that have interesting chromosomal combinations that allow you to start to study like what leads to these differences in sex. Because overlaid on that is obviously the hormone effect too, that is profound as well. So, the other thing I was going to mention is women do tend to have more kind of peripheral fat. So, in your muscle, you have a little bit of fat as well, and surrounding muscles. And it's not a bad thing. You just have a little bit, but women tend to have a little bit more than men. And so that can also influence how the muscle can generate force and behave. So then even like muscle, if you kind of look at the whole muscle level, women, like I was showing you some data, like I think the presentation you saw was one where we looked at how the relative sizes of muscles, individual muscles across the limb, across the leg, and accounting for body size. Like one of the biggest challenges I think that you see when you comb the literature to look at like differences between male and female is like, lo and behold, they always say like the male muscle is bigger than the female muscle. Well, like, no, duh. Because they're bigger, like,
because men are just generally bigger. Yeah.
right. Yeah. But so if you have to account for body size and look at how so like that's one thing we're really interested in is better understanding. We call it a scaling relationship, i.e. like if you compare a smaller female, shorter, weighs less to a larger female, accounting for that, like how do the muscles vary between them? Because they do get bigger. The bigger you are, the bigger your muscles. But obviously you have to you have more body size that you have to propel and, do all the things. So your muscles have to be bigger. Geometrically, they're just going to be bigger. So that's an important thing that we're trying to do well in my research is better account for body size so that we're not just saying like, oh yeah, male bigger than female.
Right. And that makes sense. Yeah. Not just for gender, but for other factors as well. Right.
Exactly.
Because different people are different sizes just in general.
Exactly. Yes. Yeah. I mean, a lot of, this goes to the one big project we have is we're trying to change the way research is done. So a lot of biomechanists use underlying models of the body to understand movement because you need that. Like you're studying all the external parts of the body, how people are moving, the forces forces up between the ground, the forces they're generating. You want to figure out what's going on inside the body. You need some sort of model because, we can't instrument inside the body. Like we can't stick stuff inside people. So we use models of the system. We use models of joints and bones and muscles to try to figure out what's going on. The problem is that the model that everybody's using, for the most part, based on a 5'10" man. And then you take that and then you scale it up and down. So you just kind of assume that everybody's a scaled version of that. So that's an important limitation that we're trying to change with our research.
Yeah. And I want to talk about your business as well, but is that where AI is kind of making a difference in terms of the modeling?
Yeah. So what the AI has done, and this is so the AI is so as maybe I'll just take a step back. Sure. I have a startup company that I co-founded with some colleagues at UVA, where we've commercialized some technology to go from an MRI data set to like essentially a full report of people's lower limb musculature, all their muscles, essentially using our modeling and visualization methods to provide this detailed analysis of every muscle in the body. And so that has a range of applications. And so when that process to go from MRI to this detailed set of analyses of muscle, before when we first started out was all like manual, like people had to do it by hand. And it took maybe like 50 or 60 hours to do one person.
Really?
So that was a lot, because you have to essentially get pictures. You probably get like 220 to 250 pictures, like slices of the body where you see a whole bunch of muscles, because we have a lot of muscles, about 35 per leg. And you have to, and the muscles show up in a whole bunch of pictures. So you have to outlined every single muscle. So it really takes a lot of work. So the AI came in when we said, okay, once we've done this manually enough times, we could use that to, it's called train an AI, essentially teach an AI algorithm how to do it itself by learning from like what the people, like what humans had done. That's called supervised learning. It's a way to like develop an AI model that can like now predict a new thing without so much human input. So that's the AI has allowed us to do that. So now what that's allowed us to do is study many more people because, you know, when it takes so long to do one person, you can only, for a research study, you can only do so many. And, you know, back to this whole thing about like, I was saying, we only did men because we had sort of limited number, limited availability. Well, some of that was just, there's only so many people we could do in a reasonable time frame. But now with the AI making that part faster, we can study many more people. And so we can then really delve into the things like what are the differences between sexes? How do we can look across a whole range of sizes of people, and we can just look at more of the diversity of the population, which I think is an important step.
What are the outcomes of that process? Like for like an individual demographics health. So like, how does that make women's health better? Or on the flip side, I mean, we see it I sort of see it as on a scale, but I probably shouldn't. Or like for an athlete, like how does that help our performance?
Yeah. I mean, I'll give an example because I'm going to sort of go across from our. So at the company, it's called Springbok. At Springbok, we are working with a lot of athletes, elite athletes, and so what we've been able to do at Springbok, because we've gathered enough data, is now when we do these analyses, we compare them to a normative data set. So like a bunch of non-athlete healthy people. So now we know like how muscles scale essentially change across the population. But now we have a sex-specific version. So we can say, we know like what's expected for your height and mass for a female and what's expected for a male. And as we talked about, that is different. It's not the same. So now like when we work with female athletes, we can compare them against what you expect for, a female of that height and mass, which I think what we've seen is that really does affect, how they might even perceive themselves, but also then how they might figure out like where they need more emphasis in their training or how they are recovering from an injury. So that's been really empowering to now really compare women to women. I think that seems obvious, but they are totally. Yeah.
Endurance sports should be accessible to everyone, right? That's why we are so excited to be partnering with Motive. Motive is one of the fastest growing training apps in the world today, with thousands of amateur athletes signing up every month and a nearly perfect 4.9 star rating in the App Store. You are not a template, and your training plan should not be either. Prepare for running races, triathlons, cycling events, duathlons, or swim runs, however your season schedule shapes up, and get training written by some of the best coaches in the world in each discipline who know what it takes to help amateur athletes reach their goal on race day. The app takes the training written by those experts and then creates the most optimal training plan for your schedule, abilities, and goals. Plus, the training is fully customized to your race schedule, how much you can train each week, your current abilities, and the goals you want to achieve in your race. You can use the app for free as long as you want, or get all the upgraded features from the app for just $19.99 a month. But as a Feisty listener, you can sign up at mymotive.com and use the code Feisty for 2 months of full premium access. That's right, you get 2 months of premium for free. So you quite literally have nothing to lose. So head over to mymotive.com, MYMOTTIV.com, and use the code Feisty, FEISTY. And on a personal note, I know the founder of Motive, and he is driven to make triathlon and all endurance sports more accessible for the athletes who care about their performance but who aren't quite ready for a full-time personal coach. If that sounds like you, definitely try the app for 2 months for free. You literally have nothing to lose. As a lifelong runner and triathlete turned CrossFitter, I am stoked to announce that the athletic eyewear brand Tifosi Optics has joined us as a partner here at Feisty Media. Tifosi sports glasses hit all the marks for athletes. They're shatterproof polybicarbonate, so the lenses not only reduce glare, but also offer scratch resistance, which I 100% need. They stay in place when you are moving. The hydrophilic rubber nose pads actually get more grippy the more you sweat, so they are secure and don't slide down your face even when you're running in hot conditions. No matter what sport you do, Tifosi has shades for you. Whether you love tennis, fishing, pickleball, running, cycling, or just hanging out on the beach. They are super reasonably priced, which I love, so I can have multiple pairs that go with any outfit. And of course, Feisty listeners get a special discount. So head on over to tifosioptics.com and use the code FM20. FM as in Feisty Media to get 20% off your order. That's FM20 at tifosioptics.com. I'll put a link in the show notes to make it easy for you. For decades, running shoes have been researched, tested, and designed for men. Brands have relied on the shrink it and pink it approach to sell male shoes to female customers. That's why we are so excited to be working with Hedas. Hedas designs athletic footwear for women that elevates performance, safety, and style. Hedas unlocks the science behind women's biomechanics through dedicated research, creates better shoes for women that support their longevity and performance, and establishes new design standards to promote transparency in a male-biased industry. Hedas have a lower ankle collar to reduce rubbing, a breathable mesh toe box to allow for ventilation and to allow for female toe shape, a special kind of plate in the midsole to keep tired legs going, a narrow heel cup to reduce heel slippage and take the pressure off our Achilles, and a rounded instep to create a snug fit. Hedas has 3 shoe models designed for different sessions: the Alma Cruise for long runs, the Alma Tempo for training days, and the Alma Speed for pushing the pace. I've personally been running in the Alma Cruise and I love them. It's the shoe I always wanted and never knew I needed. The fit is perfect in every way. You can get your own pair of Hedas at hedas.com and use the code Feisty20 for 20% off. That's Feisty20 at hedas.com, and it will all be in the show notes. Yeah. And how did Springbok Analytics, how did it come about?
So it was really like we had developed this technology in the lab and explored a few applications, and we to some degree we had a lot of positive feedback that, well, you might actually have something here that maybe not just a research tool that, it's a great research tool, but maybe it's something that could make an impact on the outside world. It's becoming more and more common for people in academia settings to think about taking something to develop and commercializing it as a startup. But so we decided to give it a go to say, okay, well, we think that this could be useful. It took a lot. It takes a lot to take something that's a research oriented thing and turn it into a commercializable kind of technology or a product. So that took a lot of time. We got some grants from the U.S. government to help, get going. They have some really cool ways to help startups get going with their technology. And so we got to the point that now we're working with a lot of different teams, and we have, it's been exciting to see where it's gone, but for sure, yeah, we're definitely, I am particularly excited about more and more applications in whether it be female sports or kind of women's performance in general. I think there's a lot of opportunities there that where we can have a really big impact.
Yeah, I'd love to hear, like, what are some of those opportunities? What do you see as the potential for, in particular, for the technology that you work with?
Yeah. I mean, I think, back to the female athlete, I think, it's been exciting to see so much more emphasis on, there's a lot more research, a lot more interest in helping better understand and better develop like female specific strategies for whether it be recovering from injury or improving performance, maintaining performance, training, all the different things. Well, I think our technology really empowers that because you don't have to assume something about what the person's, in our case, musculature looks like. Right. You don't have to say, okay, based on, because otherwise, when you're trying to figure out how, where somebody's weaknesses lie or whatnot, you're kind of observing them from the outside and assuming something about the inside. Well, you don't have to do that. So now you can really see what the female athlete looks like, and you can address that person specifically as compared to the female. So I think just that in general can really help women really tailor training appropriately to themselves rather than doing something that's maybe sort of one size fits all. I think there's particular areas that I'm specifically interested in. One is postpartum recovery too. Like, I think there's a lot of now better understanding about the influence, like the importance of like essentially healing and recovery from giving birth, and specifically with muscles, whether it be the pelvic floor muscles if you have a natural birth, or even the abdominal muscles if you have a C-section, or just in general, the impact of pregnancy on your musculature, I think is important. And that's something that we're really excited to like potentially kind of integrate is helping better kind of target physical therapy postpartum.
Yeah. And if you think back to the elite athlete, like if you think of a lot of training, endurance training, like I used to do, is it just this constant cycle of muscle breakdown, you hope you don't take it too far, and then you go again, right? So if our timing on that slightly off, or if there's ways that we can recover better from every training session, it's mind-blowing to me how much faster we could potentially improve at our sports, right? Am I delusional, or is that right?
No, that's right. That's right. The other thing that's totally right. The other thing I was going to mention is the nutrition aspect actually is something that I think we're seeing is like intersects with what we're doing really well, because obviously as you're training, you're trying to optimize your nutrition to increase muscle mass efficiently. And the challenge that the thing that we see sometimes and we've seen it in some female athletes is actually when you're strength training, you really do have to have enough nutritional input. Otherwise, even though you're strengthening some muscles, sometimes we see other muscles get smaller and weaker. Really? Maybe not externally noticeable, but yeah, for sure. And so I think especially for, and I think that's different for female versus male, just all the metabolic differences and everything. So that's another thing that I think is important.
Yeah. Why is that? Do you think is that if we take in protein, does it help? Like specifically, how do we stop this muscle shrinking?
Yes, you have to eat more protein. Yeah. Okay. Essentially, one way to think about it is that if you are you're building protein, you're adding protein to a certain muscle, so that has to come from somewhere. And so
Right.
if it's
Right.
not enough from what you're eating, then it's going to essentially steal from something else. um,
Yeah.
which is fascinating, isn't it? It's kind of intuitive, but for sure, that's something that um, I think this sort of you know intersection between like the training, the nutrition, and the muscle health is one that is very important. I think will help like women stay healthy for longer.
Right. And we have an online course called Fueled. And we talk a lot about how much protein women need to have, in particular as we age too and go into perimenopause and menopause. And I've never heard that I've heard related to hormones and needing to have more protein for muscle recovery, but I've never heard that women are more likely to take that protein from another muscle when we're trying to build strength. It's like,
Well, I will say, I
no.
think that phenomenon can happen in men too. I don't think
Right.
it's specific, but we see it like in practice happening with more in women. And I think maybe it's just like it's men, maybe it's the athletes that we're studying, whatever it is, tend to have better protein intake. It could just be
Well,
that, like
yeah,
they're
and we have
like,
seen
yeah,
more low energy availability in women too.
right. Mm-hmm.
Typically, on
Yeah.
average, again, that obviously that can happen
Mm-hmm.
in men. Those types of things where
Right.
I think there's an intersection between things that
Yeah.
are
Like
happening. And again, that's
cultural and yeah. Mm-hmm.
yeah,
Yeah.
yeah, and that's how we need to study women, right?
Exactly. Yes, we need to study women because that like all those things matter. And we could actually really change culture as well if we really better understand like the impact of being low energy or not having enough protein.
Yeah, I absolutely agree. Are there outcomes from what you're seeing in your research or in your colleagues' research for um more for medicine or for health broadly?
Yeah. I mean, we do one other area that we're interested in is like helping better recovery from injury, but also surgeries, for example, like
Mm,
ACL repair. Obviously,
mm,
when you have an like a major surgery like that, it impacts your muscles for sure. And so we're interested, like, and interestingly, it's not just the muscles that you think of. Like most people think, okay, your quads after you have an ACL are going to get weak because they're kind of inhibited. Actually, your body doesn't want to use them for a little while. But actually, we see other muscles affected. So we're really excited to help fuel like the recovery from different types of surgery. So that's one natural one. We also another one like that is like shoulder assessing shoulder muscles and people that have rotator cuff tears and helping better understand or better predict outcomes of those surgeries. Another one we're actually kind of exploring now is muscle wasting in
mm,
diseases, in particular in cancer.
mm.
How assessing muscle health over time and how, especially nutritional interventions, influence muscle wasting in these various conditions. So lots of different things. But
Wow.
yeah.
Yeah, so interesting. And what do you see like in the future for women's performance, in particular related to some of the tech trends that you're seeing? Like, what do you see for the future of our health or even for women's performance in sports too? Like, do you see us continuing? Because I know that women are improving on average more in a lot of sports, like faster, I'd say, in a lot of sports than the men are.
Mm-hmm.
Do you see that
Yeah.
continuing?
Yes. Yes.
Mm.
For sure. Yeah. No doubt. I mean, one of my so um, what's I think that's so interesting to me is even if you track like speeds, like like the 100-meter time, right? And in the Olympics, male and female. Um, what you're tending to look at, like if you wanted to compare them, you might look at the same year, like what the record is, right? And of course, the male is faster than the female, but it's actually shifted. Uh, like
Hmm.
if you looked back in time, there is a point in time where the male time was the same as the female, the time now, right? Which makes sense. Like female women weren't doing these things like it
Mm-hmm.
took a lot longer till many women participating in sports. So
Mm-hmm.
it would make sense that like we haven't evolved and grown into like that level of performance. So yeah, no, I mean, I think for sure, like I'm a huge fan of women's elite sports. I'm a huge, like, back to tennis. I'm a avid tennis player. I'm like a total WTA nerd. I follow all the players, and I've looked at, like, I like to study like their different uh you know performance measures, but like, women are right in there, in terms of like even like basic metrics like a forehand speed. There's some women that are like outperform, hit it faster than the men for sure. There's all sorts of stuff like that. So, yeah, no, I think the female sports is like, it's like, I feel like it's hit an inflection point, and
Yeah, it has. Mm-hmm.
yeah, and it's really exciting to see. I love it.
Mm-hmm. Yeah, and I've never really, as much as I think about like women's performance all the time, I've never really thought about it in terms of the AI factor, in terms of like how we can correlate information. I mean, put it into a machine and have it spit out more information that we could have had before. And then also, the fact that we're only now kind of asking questions about, like, more questions about women and researching women more. And I think
Yeah.
you said, we were talking before the show that you're seeing more kind of grad students come through who are female and asking questions about women. What kinds of questions are, like, the next generation, like what kinds of questions are they asking in terms of the research that you see?
Yeah, no, I mean, running the gamut, but definitely many, like, the female grad students are really interested in women's health as a whole, like
Mm-hmm.
whether it's because they've experienced something or somebody in their family or whatever it is, it's more resonates with them. But they also, they're really smart. They see gaps, and they don't think it's right. Especially like the younger generation is very like astute to like kind of justice and wanting to do good in the world. And I think they see that, like even maternal health is just like abysmal still for our
Mm-hmm.
in our in the US.
Yeah.
And a lot of that is because it's just been under um, essentially studied, or lack of focus on women's health issues. So, the next generation's like, that's not cool. Like, we need to solve that. And that, and there's just it's great to have opportunity for impact too.
Mm-hmm. Yeah,
But
so great. Well, I'm so excited about the research you're doing. Thank you for, like, the time that you take to ask the right questions. And also, even this company, Springbok Analytics, it sounds like there's a lot of exciting futures for female health and performance. So thank you so much,
yeah,
Silvia.
awesome. Thank you for having me.